The National Electrical Code, specifically Article 695.3, differentiates between power sources and feeder sources. It is important to understand this distinction when designing and installing fire pump systems or other critical systems requiring reliable power. A power source is fundamentally a source of electrical energy. Examples of power sources include the utility grid, an on-site generator, or even a battery system. These are the primary origins from which electrical power is derived. A feeder source, on the other hand, is a circuit that connects a power source to a load. Think of it as the pathway that carries electrical power from its origin to the equipment that uses it. The requirement for multiple sources, as outlined in Article 695.3b, is primarily intended to ensure that a backup power source is available automatically in the event that the primary power source fails. This is a critical safety measure for systems like fire pumps, which must remain operational during emergencies, even if the main power supply is disrupted. The code provides several options for achieving this redundancy. Firstly, a combination of two or more individual sources can be used. This could involve having two separate generators, each capable of supplying the required power. Alternatively, it could be a setup with two independent utility feeds coming from different substations, providing diverse power pathways. A third possibility is a combination of a generator and a utility feed, offering both on-site and off-site power options. Secondly, a combination of feeders constituting two or more power sources can be employed. This approach involves utilizing two or more feeders that originate from distinct power sources. For instance, you could have two feeders coming from different substations within the utility grid. This provides redundancy by ensuring that a failure in one substation does not completely cut off power to the system. Another option within this category is to have two feeders originating from separate generators, offering a similar level of redundancy but with on-site power generation. Thirdly, a combination of one power source and an on-site standby generator is a viable solution. In this configuration, the primary power is supplied by a standard power source, such as the utility grid. However, in the event of a power outage, an on-site standby generator automatically kicks in to provide backup power. This ensures that the system continues to operate without interruption, even when the main power supply is unavailable. If you have determined that multiple sources are necessary because you have an unreliable primary power source, and option 1 is not feasible, as you do not have two individual sources readily available, you are left with options 2 and 3. Option 2, involving 4 feeder sources that constitute 2 power sources, might seem complex. Option 3, utilizing 2 feeder sources and 1 on-site standby generator, may appear to be a more straightforward and practical solution. It's important to carefully consider the implications of interpreting the code in a way that necessitates 3 or more transfer switches with delays in switching over. While such an interpretation might be technically possible, it could lead to an unnecessarily complex and potentially less reliable system. The core intent of the code is to guarantee a backup power source in case the primary source fails. Achieving this with 2 feeder sources and an on-site standby generator is generally sufficient and aligns with the overall safety objectives. It is highly recommended that you engage in a discussion with your local electrical inspector to gain insights into the specific interpretation of the code within your jurisdiction. Local interpretations can vary, and obtaining clarity from the inspector is crucial to ensure that your installation meets all applicable requirements and safety standards. In summary, understanding the distinction between power sources and feeder sources, and the various options for achieving redundancy, is paramount for ensuring the reliable operation of critical systems. Always consult with local authorities to ensure compliance with all applicable codes and regulations. The National Electrical Code Article 695.3 outlines crucial requirements for power sources serving fire pumps, and careful consideration of these requirements is essential for ensuring the reliable operation of these life safety systems. Firstly, it is vital to differentiate between power sources and feeder sources as defined in the code. Secondly, understand that the requirement for multiple power sources stems from the need to ensure a continuous and reliable power supply to the fire pump, even in the event of a failure of the primary power source. The code provides several options for achieving this redundancy, each with its own advantages and disadvantages. The code emphasizes the importance of selecting a power source that is reliable and capable of providing the necessary power to the fire pump under all operating conditions. This includes consideration of factors such as voltage stability, frequency stability, and short-circuit capacity. When evaluating potential power sources, it is important to consider their ability to withstand various disturbances and faults that may occur in the electrical system. This includes voltage sags, voltage swells, and short-circuit conditions. The power source should be capable of providing sufficient power to the fire pump during these events without causing it to trip or malfunction. The code also addresses the issue of coordination between the fire pump power source and other loads on the electrical system. It is important to ensure that the fire pump power source is sized and protected in such a way that it does not overload the electrical system or interfere with the operation of other critical loads. In addition to the requirements for power source reliability, the code also specifies requirements for the installation and wiring of the fire pump power source. This includes requirements for overcurrent protection, grounding, and isolation. These requirements are intended to minimize the risk of electrical hazards and to ensure that the fire pump power source is properly protected from damage. Furthermore, the code requires that the fire pump power source be provided with a dedicated disconnecting means that is readily accessible and clearly labeled. This disconnecting means should be capable of disconnecting the fire pump power source from the electrical system in the event of an emergency. The location of the disconnecting means should be carefully selected to ensure that it is easily accessible to authorized personnel, even during a fire or other emergency situation. The code also addresses the use of automatic transfer switches for fire pump power sources. An automatic transfer switch is a device that automatically switches the fire pump power source from the normal power source to an alternate power source in the event of a power failure. The use of automatic transfer switches can significantly improve the reliability of the fire pump power source, but it is important to ensure that the transfer switch is properly sized, installed, and maintained. The code specifies requirements for the testing and maintenance of fire pump power sources. This includes regular testing of the power source to ensure that it is capable of providing the necessary power to the fire pump. It also includes regular maintenance of the power source to ensure that it is in good working condition and free from defects. The testing and maintenance of fire pump power sources should be performed by qualified personnel who are familiar with the requirements of the code and the operation of fire pump systems. Proper documentation of the testing and maintenance activities is essential for demonstrating compliance with the code and for tracking the performance of the fire pump power source over time. When selecting and installing a fire pump power source, it is important to consider the specific requirements of the fire protection system and the building in which it is installed. This includes consideration of factors such as the size and type of fire pump, the water supply requirements, and the occupancy classification of the building. The fire pump power source should be sized and configured to meet the specific needs of the fire protection system and to ensure that it can provide the necessary power to the fire pump under all operating conditions. In addition to the technical requirements of the code, it is also important to consider the economic aspects of fire pump power source selection and installation. This includes consideration of factors such as the initial cost of the power source, the operating costs, and the maintenance costs. A careful analysis of these costs can help to ensure that the fire pump power source is both reliable and cost-effective. In conclusion, National Electrical Code Article 695.3 provides comprehensive requirements for power sources serving fire pumps. Compliance with these requirements is essential for ensuring the reliable operation of fire protection systems and for protecting lives and property from fire. By carefully considering the requirements of the code and by working with qualified professionals, it is possible to select and install a fire pump power source that meets the specific needs of the fire protection system and the building in which it is installed. The NEC makes a distinction between power sources and feeder sources because these serve different functions in an electrical system. Understanding this distinction is crucial for ensuring the reliability and safety of critical systems like fire pumps. A power source is the origin of electrical energy. It could be the utility grid, a generator, or a battery bank. It's where the electrical power is initially generated or stored. A feeder source, on the other hand, is the circuit that carries electrical power from the power source to the load. It's the pathway that transmits the power from its origin to the equipment that uses it. The requirement for multiple power sources in NEC 695.3 B is intended to ensure that a backup power source is available in case the primary power source fails. This redundancy is vital for systems like fire pumps, which must remain operational during emergencies. The options provided in NEC 695.3 B are designed to offer flexibility in achieving this redundancy. A combination of two or more individual sources could involve two generators, two utility feeds, or a combination of a generator and a utility feed. A combination of feeders constituting two or more power sources might involve two feeders from different substations or two feeders from different generators. A combination of one power source and an on-site standby generator is another common configuration. If the primary power source is unreliable and having two individual sources is not feasible, options 2 and 3 become relevant. Option 2, requiring 4 feeder sources to constitute 2 power sources, may seem complex. Option 3, using 2 feeder sources and 1 on-site standby generator, might be a more practical solution. The intent of the code is to ensure a reliable backup power source, not necessarily to mandate an overly complex system with multiple transfer switches. It's important to interpret the code in a way that aligns with its underlying purpose of ensuring safety and reliability. Discussing this specific situation with the local electrical inspector is highly recommended. They can provide guidance on how the code applies to this specific project and ensure that the chosen solution meets all applicable requirements. The NEC focus on both power sources and feeder sources reflects a comprehensive approach to ensuring the reliability of critical electrical systems. By understanding the distinction between these elements and the various options for redundancy, engineers and installers can design systems that provide dependable power, even in challenging circumstances. Remember that the ultimate goal is to provide a safe and reliable power supply for essential equipment, and the code provides a framework for achieving this objective. The NEC is not just a set of rules, it's a guide to best practices in electrical safety and design. By understanding its principles and applying them thoughtfully, you can create electrical systems that are both code compliant and highly reliable. Always prioritize safety and consult with qualified professionals when designing or installing electrical systems. They can help you navigate the complexities of the code and ensure that your work meets the highest standards of safety and performance. The NEC undergoes regular revisions to reflect advancements in technology and evolving safety concerns. Staying up to date with the latest edition of the code is essential for all electrical professionals. The NEC is a living document, and its ongoing evolution is a testament to the industry's commitment to continuous improvement in safety and reliability. By embracing a culture of learning and professional development, you can stay at the forefront of the electrical industry and contribute to a safer and more reliable electrical infrastructure. The distinction between power sources and feeder sources is not merely a technicality, it's a fundamental concept that underpins the entire NEC. Understanding this distinction is essential for anyone involved in the design, installation, or maintenance of electrical systems. By grasping the nuances of these concepts, you can ensure that your work meets the highest standards of safety, reliability, and code compliance. The NEC is a valuable resource for electrical professionals, and its proper application is essential for protecting lives and property from electrical hazards. By taking the time to understand its principles and requirements, you can contribute to a safer and more reliable electrical world. Remember that electrical safety is everyone's responsibility, and by working together, we can create a safer and more secure electrical environment for all.